YouTube. We're live on YouTube.
Live on YouTube. Whoop whoop.
We are live on Instagram.
Very full. Thank you. Sorry, we're live right now. I was like,
Boop 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 boop. What's that heavy sigh for?
Well, because I had to reconnect everything, I might need to restart the. And why did this go? Just a simple man that wants to go live on time. Is that so much to ask?
It's too much to ask. Okay, let's see. I need Bamboo Studio.
But don't do it right now, please.
I know. I'm just filling time right now.
You are live on YouTube.
I'm live on YouTube, but I can't see anything.
Oh.
But if there's any questions y'all have, just pop them into the comments.
So you still don't see anything here?
Correct. So what I'm doing right now, YouTube friends, is I got a new computer, so that's very exciting. But that means that we're having some technical difficulties in some other arenas, of course. But so what I'm doing is I am trying to print out. I've been using this coffee canister for a while. The general, generic, unbranded coffee. I need a new coffee mug, or not a coffee mug, a new pen holder, because also I can't see inside of these, so I need it to be shorter. I found some cute ones on Thingiverse, or Thingiverse. So I'm going to do that. I also am going to try to print out, I'll probably end up just designing it myself on Tinkercad or something, a base for a lamp that was a hanging lamp, but I want to flip it over and have it just be like a table lamp. I think that'll be cool. So that's what I'm doing. Don't know if anybody's watching. But if you are, welcome.
Why don't you just bring up the TikTok?
I don't have TikTok Studio on this computer.
You don't need it. You just need to log on to TikTok and look at your own stream.
Okay. Oh, there we go.
There we go. We're not live on TikTok yet.
Do you want me to go live?
Yes, please.
Okay. Okay. It's been a while. Invite another creator to co-host. I don't want to do that. All right, guys, welcome to Math Thursday. So if you're new here, welcome. If you're not so new here, you know the drill. If you have any math questions, any concepts that you want me to go over, we kind of tend to focus primarily like pre-algebra all the way through like algebra 2, some pre-calculus. But if you're looking for calculus help, I'm not going to be a huge help for you. This is not quite the channel for that. But for pre-algebra to algebra 2 to trig to pre-calc and all parts in between, you are in the right place. So I know that we're getting close to, I think there's like some midterms coming up. A lot of you are probably on spring break. I'm on spring break right now. Let me know in the chat, how long is your spring break? Do you get 1 week or 2 weeks? Because we get 2 weeks, and it's really nice. But yeah, let me hear from you guys. If you have any questions, concerns, comments, regrets, but just if you have any topics that you want to go over or questions that you have, we're also trying to kind of talk about and come up with some ideas for like summer, right? What kind of summer work support help are you guys interested in? Do you need anything like that? All right, so we are off and running. So we've got right triangle trig. Yes. Start off with a bang. I really need more expo markers. All right, so let's start it off with right triangle trig. So right triangle trig, so trigonometry is where you are kind of joining, not kind of, you are joining like the sides and the angles of a triangle. So, you know, right triangles, we know that their relation, or the side length relationship is always going to be the same, right? The relationship between the side lengths of a right triangle, so we'll say like leg and hypotenuse, right? So we know that the relationship between these three sides is always going to be the same, right? And what they are all the same is that we've got the leg squared plus the leg squared equals the hypotenuse squared, right? It's the Pythagorean theorem. So with the Pythagorean theorem, that limits us to that relationship between all the sides, right? That a squared plus b squared equals c squared. No, I tend to move away from the a squared plus b squared equals c squared, because if you have this one labeled as a, or this one labeled as a, or this one labeled as a, it doesn't really matter which one's a, which one's b, which one's c, really, as long as you know that it's the two legs squared and then equals the hypotenuse squared, you're going to be in good shape. Thank you, Sunset Chaser. I have really good handwriting. It's really nice to be able to like post notes and things that are very clear and they're very easy to read. But here's the thing, is that when you're doing some sort of activity where you kind of don't really want to put your name on things, right? The anonymous things, it never works for me because everybody knows my handwriting. So that's one drawback, but thank you. So leg squared plus leg squared equals hypotenuse squared. Okay, so that's how we go about it. So we know that this relationship between all the side lengths of the triangle will always be true, right? Trigonometry relates, it kind of takes it a step further, that it says, it's that improv rule, right? Yes, and. So yes, this is true. And the angles will always be a specific ratio as well. Okay, so like based on the angle that you have is also going to determine the ratio of the other sides. So those ratios between the sides of the triangle relative to the angle, that is what trigonometry is. So trigonometry is going to relate those angles and the side lengths, and they're always a set ratio. Okay, so the ratio So we have our trig ratios. And those trig ratios, these are always true, even though we always start with just the right triangles, right? We start with the right triangles because, I mean, that's where they're kind of the easiest to double check with Pythagorean theorem. But then you can get into law of sines, law of cosines, and all of that. So the trig ratios, again, are relating that, like, if you know what this angle is here, then this leg and this hypotenuse will always be in a specific ratio. Okay, if you know what this angle here is, then this leg and this leg will always be in a specific ratio. Okay, now those names, or those the names of those ratios are those weird things. You know, everybody kind of goes like on their calculator and they're like, what is, you know, especially, oh my gosh, especially like high school students when they first get their calculators and they're like, you know, all of a sudden there's all these letters and words on the calculator and they kind of go like, what is sin, cos, and tan, right? Okay, which class do we study that? So trig primarily starts showing up in some Algebra 1 classes. We'll get to it, which is around like 8th or 9th grade. But you can also have this you really hit it hard in Algebra 2 and pre-calc especially. But Algebra 2 especially does get into trig ratios. Okay, and I have lots and lots of videos. If you check out my other channels, T2 Pretty, there's lots of other videos about this. But if you have something else, like if you have something else that you want me to go over as I'm working through this, just pop it in the chat and I'll try to get to it. Okay, so the trig ratios, we use this symbol called theta. Okay, so that 0 with like a little slash through it, that is called theta. Okay, and that represents our angle measure. Okay. Seventh in algebra, what? Yeah, I mean, it's 7th grade algebra 1. Like, there's lots of other things. Most middle school maths kind of go through like pre-algebra and algebra. And things like that. So yeah, you know, ultimately, like, there's no rush to get through whatever math class you want to get to or get through. Like, I always want to make sure that my students are in the best placement for them. Okay, so when we're talking about the trig ratios, if we set, let's see. So if I have just a right triangle like this, okay, and if I set this angle here as theta, what that does is now I've got a couple different names. So these are still the legs and this is still the hypotenuse. The hypotenuse doesn't change. So this will always be the hypotenuse. Now if this angle here is theta, across over here we call this the opposite. I need to get my finer markers up. Hold on. So this one across here is my opposite, because it's across from theta. Okay, this one here is my adjacent, because it's adjacent to theta. And again, this is hypotenuse is the hypotenuse. So the ratios, remember we talked about how that angle, whatever that angle measure is, those sides are going to be in a specific ratio, just like similar to Pythagorean theorem, right? So what we want to do is we have sine is our first trig ratio that we usually talk about. So sine theta, sine really just means the ratio between the opposite and the hypotenuse. Okay, so again, a trig ratio, sine of this angle, okay? This is what we're looking at. So sine is the relationship or the ratio between the opposite and the hypotenuse. No matter the side lengths, right? This angle determines that ratio. It will always occur the same, okay? Okay, let's see, so there's opposite. All right, so then the other one is cosine, or another one is cosine theta, which is the ratio between the adjacent and the hypotenuse. And then the third one is the tangent. So tangent of theta is the opposite over the adjacent. Okay, so with those ratios right there, you can solve these triangles. Okay, you can figure out these missing side lengths if you know 2 bits of this information. Okay, yes, I do have YouTube also. Go check me out over there. I'm there too. Okay. Well, T Pounder, you're here. I'm making math pretty easy. The organic chemistry tutor, he has a great channel too. I would say we're pretty similar. Anyway, so here we go. So with these different ratios that we've got, we can solve these different sides of the triangles. Okay. Let's see. So with a ratio, so usually what you're given, oh, yay. Congratulations. Is that Tia? Congratulations. Okay. Oof. Asking for Calc 3. Oof. You know, Calc 3, I did take 3 years of calculus. So usually on this channel, we tend to focus more on like the pre-algebra or like upper elementary into like trig. But here's the cool thing, T-Pounder, is if you post your question in the chat, a lot of times people on here will be able to help you out with it. So put your question in there because somebody might have a good resource or something. It's a great community that we have going on here on Math Thursdays. Okay. So, so then CSC, COT, and SEEK. Yes. So, all right. So Math 1. So Caleb, to recap, so sine, cosine, and tangent, these are all ratios of these side lengths in the right triangle. Okay. So let's, so now cosecant, secant, and cotangent are just the like inverses of these. Okay. Or the, I guess, reciprocals of these. So like cosecant, which is CSC, is hypotenuse over opposite. Secant, which is SEC, is hypotenuse over adjacent. And then cotangent, which is COT, would be adjacent over opposite. So there is also, yep, there is a nice little rhyme, I guess you could call it, to help you remember this, and it is SOHCAHTOA. So you can see in the chat, there's a bunch of people. So S-O-H, sine is opposite over hypotenuse. You can do SOHCAHTOA. Okay. So we've got sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. That's what we've got. So SOHCAHTOA. All right, so let's see what if, okay. If I said sine theta is 3/5. Okay, so if you're given this information, okay, all right, so if you're given this information and it says like find the missing side of the triangle, well, what you have sine, which is the opposite over the hypotenuse. So we can set theta to be actually either one of these. It doesn't really make a difference. But what we do know is that sine is the opposite over the hypotenuse. So that means that you've got 5 here, all right? And then sine of theta is 3 here. So we've got opposite over hypotenuse, okay? So now what we can do is we can, let's see. So now if we need to find the other side here, what do? We have a right triangle. We've got two sides. Pythagorean theorem is still always going to be the right thing. It's always going to work with right triangles. Okay, so what I can do is if I have this, is I can just set this as b, or I can use whatever variable I really want to. Okay, but I can say that 3 squared plus b squared equals 5 squared. So again, this is just Pythagorean theorem. Okay, so then I would say b squared equals 5 squared minus 3 squared. So b equals this. Now I know I'm kind of doing this in a weird way, but it's because I just want to show you that if you can visualize that this is going to be like the hypotenuse squared minus those legs squared and then square root of that, right? Then I would just do square root of 5 squared minus 3 squared. Or you might recognize that this is a 3, 4, 5 triangle. Lovely. Okay, so then my leg is going to be the square root of 25 minus 9, which is the square root of 16, which is 4. Yes, it could be plus or minus 4, but since we're talking about side lengths of a triangle, we're not going to have a negative side length. So b is 4. So that means that our side over here is 4. Okay. So we've got 3, 4, 5. So then what we could also do, usually a follow-up question to this with your teacher would be to find the other values, right? To find the other trig ratio. So we would say that cosine theta, cosine is adjacent over hypotenuse, so that's 4 over 5. Right? And then we have tangent theta, which is opposite over adjacent, which is 3 over 4. Okay? And then with cosecant, secant, and cotangent, you would flip those. Okay? All right, let's see. Why can't you do 5 minus 3 if you're squaring? Because 5 minus 3 is not the same thing as 5 squared minus 3 squared, even though it's the square root. Because 5 squared minus 3 squared, I mean, so if this ended up being that it was, I mean, because 5 minus 3 is 2, right? So it's not going to end up being the same thing. Okay? Let's see. Oh my goodness. Okay. I missed a lot in the chat. Let's see. It is, so right guy, it is a 3, 4, 5 triangle, but it is not a 30, 60, 90 triangle. 30, 60, 90 triangles are a little bit different. 30, 60, 90 triangles is a special right triangle, but it is not a 3, 4, 5. So one thing is like, so kind of on a follow-up. So once you are able to figure out these, oh no, we almost lost the whole jar of markers, guys. That was almost really bad. Okay, so once you figure out this, if we wanted to figure out what our, once we figure out what our side lengths are, we could figure out our angle. Okay. So Keelan, sorry, I'm not sure. So I did this. So this is all from the Pythagorean theorem. Okay. Because I had b squared over here. So I have b squared equals 5 squared minus 3 squared. So I needed to do this b. So that's why I needed to do a square root of both sides. So this is all just from the Pythagorean theorem. That's what I'm following along with. And so Pythagorean theorem is where we have a squared plus b squared equals c squared. Okay. Okay. All right. So once we have this, that sine theta is 3 over 5. So we can use these trig ratios to also figure out what the angle is, because we know 2 of the sides. And like I said before, right, on a right triangle, or on any triangle, right, you can use trig to figure out any triangle. But what you can do is David, that's pretty good. I like that. Okay, what you can do is you can get that theta equals, you can use this sine -1 of 3 over 5. And where that is if you look on your calculator and you do like the second sign or shift sign, it's sort of like, oh, the real big math nerds hate when I say this, but it's sort of like you're kind of like dividing by sign just to get the theta by itself, okay? So I'm going to do shift sign, it's arc sine, 3 divided by 5. So I get 36.86989, some really crazy number. So what we do is usually we round angles to the nearest whole degree. And so we'll go with theta equals 37 degrees. Okay. So a 3, 4, 5 triangle is not the same thing as a 30, 60, 90 triangle. A 30, 60, 90 triangle is a special right triangle. Okay. And let's see, this is 30 and this is 60. Okay. So what this is going to do is across from the opposite from the 30 degree would be like A, that's sort of like your value, right? Your initial value. The hypotenuse of a 30, 60, 90 is always going to be 2 times the shorter leg length. It just always is. And then across from the 60, it's going to be the leg times √3. That is how it always works out. Okay, so this is not the same thing as the 3, 4, 5 triangle. This is a 30, 60, 90 triangle. But what's interesting about that is that if you go in and you do, okay, well then let me do, what is sine of 30? Right, so remember I said how the lengths will always end up in the same ratio, right? So sine of 30 would be the opposite over the hypotenuse, which would be a over 2a, which will always be 1/2. And you can check that on your calculator as long as you're in degrees mode, and you can do sine of 30, and it gives you 1/2, okay? Because you've got this, the hypotenuse is always 2 times the length of that shorter side, okay? So again, there's a lot of moving pieces with this, but trig is pretty straightforward once you understand those basic trig ratios. Now, when I was in high school, it took me a long time for it to click in my brain, okay? I'm always very honest that like I really struggled with math in high school, which I think is what kind of drew me to become a high school math teacher. And also to do this channel, right? That I get it. Like I understand that a lot of this stuff is very easy for people, but I know that a lot of this stuff is very difficult for a lot of people too. So it's okay. If this clicked with you right off the bat, that is amazing. Congratulations. It did not click with me right off the bat. Whew, no, lots of tears, okay? It does not click with everybody, so everybody's gonna get there at their own pace, okay? But I promise you that it is not overly complicated. It is not overly complicated. It is simple. But remember, I always say, simple does not mean that it's easy, right? Simple doesn't mean easy, okay? But it's doable. It's figure outable. We can get there, right? Okay. You can do this in your head with the unit circle, sure. But again, I struggled with the unit circle because until you are ready to pick up on those patterns and things like that, the unit circle looks like complete gibberish to a lot of people. To a lot of students, it looks like complete gibberish until you start to really break it down. And a lot of people will kind of put up those roadblocks, right? And I'm trying to encourage you guys to take those roadblocks out, right? Don't put them out, like don't give up before you've really tried something, okay? So I teach primarily 10th grade this year, but 10th and 11th grade is, that's the wrong mouse. 10th and 11th grade is what I primarily teach. Pancake mix. Algebra 2 honors. I can absolutely help with Algebra 2 honors. Okay. Yeah, if you memorize the unit circle, that's great. Arc sine and sine -1. So I always just say I honestly, like when I'm teaching this, when I'm saying how to figure out the angle measurement, I just say, like, I say second sine because that's the calculator key. But you can also say arc sine, you can say sine -1. All of those things are kind of the same, right? So this is primarily algebra 2. How do you find tangent? Do you mean finding tangent of like a triangle like this? Or so tangent of this. So tangent, let's just stick with tangent of 30, would be opposite over adjacent, which would be a over a root 3, right? Now most teachers don't want you to have that root 3 in the bottom. So you would do something called rationalizing the denominator, which means you would multiply by root 3 over root 3. And what that does is that gets rid of this radical down here. So what you're left with is a times root 3 on the top over 3a down here, which is just root 3 over 3. Because the a's cancel. Okay. That is something that I don't require all of my students to do, especially when we're first learning this, because personally, I had a hard enough time just figuring out what the ratios were and how to figure out the angle and the side lengths and putting it all together. And so this, I feel like with rationalizing the denominator, that might have been what just broke me. And I just said like, I'm done. I can't do this. Okay. But then you have a mindset shift. It's been a long week and I'm on spring break. Woof. Okay. Let's see. So proofs, I don't really like doing proofs on here because it's really, well, first of all, I hate proofs. But also because it's really just kind of like logically walking your way through these things. But with like similar figures, similar triangles, there are those shortcuts, right? Like ASA, SSS, like those types of things. Or like the angles, right? There's different ways to do that. But yeah, writing out proofs in this format in particular is really difficult. But if you need some individual one-on-one help, please make sure to send me an email or click the link in our bio and profile and all that. You can set up a one-on-one tutoring session. Okay. So let's see. So we've got, so factoring polynomials was something that I saw earlier. So factoring polynomials and looks like area. What's the furthest level of math that I know? So in college, I was a biochemistry major, which required me to take some, more advanced math and statistics classes. I did like statistics for like science majors, so chi-squared, all that kind of stuff. But I did do 3 years of calculus, but it has been so long since I've done that. So my kind of the sweet spot, if you will, for my math knowledge and what I really enjoy talking about is like pre-algebra, like middle school math, up through like algebra 2, trig, pre-calc, a bit, but yeah. Oh, Dominic, I love chemistry. I love balancing equations. Dare I? Linear algebra at the college level, that's a little bit beyond the scope of this channel, but Again, pop your question into the chat because sometimes there are people in here that'll be able to help you out with that. Let's see. Oh, law of cosines and law of sines. Okay, so let me, I'm gonna start, all right, so polynomials, factoring, and area formulas. So area formulas, I'm actually gonna start with that one. We just did SOHCAHTOA. Let's see, law of sines and cosines. Okay, so I've got this little list going here. Okay, so when we're looking at area formulas, okay. All right, let me pull up my formula sheet. I always like to go off of the formula sheet that is given to you for the SAT questions. And that's a little thing that I use with my students, and you know, I always encourage that with other teachers too, is to like they give you those formula sheets. So on there is like special right triangles are on there, and things like that are all on there. So the area of well, the area of any parallelogram, I think that's what it was somebody was asking about, like this, like with a parallelogram. Oh my gosh, I am rusty with my diagrams. Okay, so we've got this parallelogram, right? And then what might be happening is somebody said with a triangle inside. I'm not sure what that really means, but if we have, so area of a rectangle or a parallelogram, or like the vast majority of quadrilaterals is base times height, okay? That's what it's going to be, okay? So even if you are, so that's even with like a triangle, right? A triangle is 1/2 base times height. I get that, okay? But so if you had, like, this would be your height, and this would be your base, or your length, or your width, or whatever you want to call it, right? The length times the width, base times the height. Okay, so the area of this would just be base times height. Okay, when you're talking about volume, when you have some sort of, well, I'll use this here. Okay, so when you have like a 3-dimensional solid like this, right? So this would be a cylinder, right? So we've got a cylinder here, and volume is how much space it's taking up, right? Or how much space it contains, or mass it contains, right? So it's sort of like area is how much space it would like cover up on a grid or on a piece of paper, right? Because it's flat. But volume is where you take that like footprint and then talk about how big it is or how much space it takes in all dimensions. So that's why you have 3 dimensions that you're talking about. So so that's why, like with a rectangular prism like this, right? Like this little eraser that's a little rectangular prism, right? You have this layer on the bottom that would be like the area. But so the area gets you those 2 dimensions, and then that 3rd dimension, which is going up, that's what you also have to multiply by. So the volume of any prism, which means it's a cylinder, right? It's a rectangular prism like this, like any of the building blocks where the 2 ends of it are identical. Okay, so you've got those 2 ends of something are identical. So I'm not talking about cones. I'm not talking about pyramids. Okay, so any prism is going to be the area of the base times its height. That's it. That's the volume. Because it's sort of like you take the area that it covers up here, and then you multiply it by how tall it is. That's it. That's all you do. Okay, so if it's a cylinder, you find the area of the circle times the height. If it's a rectangular prism like this, you find the area of the bottom times the height. That's that 3rd dimension that you're multiplying by. Okay, so with a pyramid or a cone, where you don't have like a prism, remember a prism is the same shape on either end. A pyramid or a cone is going you've only got one face. That's the shape, and then the other end is a point. So it all goes to one point. So in that case, you still do the area times the height, but since it's going to a point, you divide it by 3. So it's 1/3 of the area of the base times the height. That's it. Okay, it can be a cone, it can be a pyramid, it can be a square-based pyramid, it can be a triangle-based pyramid, it can be a trapezoidal-based pyramid. Area of the base times the height divided by 3. Or if it's a prism, right, where it's the same shape, top and bottom, area of the base times the height, done. Doesn't matter what the shape is. It's always the same. Okay, remember, the pattern doesn't change, right? It's always going to be the same. Okay? All right, let's see. Oops. All right, so we've got some SAT, ACT problems. You know, take a look at the SAT math formulas, and you should be able to have a pretty good idea of what to do. So reviewing basic trig ratios, like right triangle trig, like we were just doing, and making sure that you're really comfortable with using the formulas that are given to you. Special right triangles will be given to you. In fact, oftentimes, so the vast majority of the math that's on the SAT and the ACT really only goes up to Algebra 2. There may be some trig on there, but it'll be pretty basic right triangle trig. Very rarely do they have law of sines and law of cosines on there, and a lot of times, usually they'll even give you the law of sines or law of cosines on there. Annabella, a squared plus b squared equals c squared. That is the Pythagorean theorem. It's for finding the side of a right triangle or determining if it is a right triangle. Okay. Polynomials factoring. Okay. Got too many mices on here. I am good with geometry. So geometric mean, Presley, what level of math are you talking about? Because the geometric mean, there's a couple of different kind of levels that you could go with. Okay, but are you talking about it with figures or lists of numbers? Okay, so figures, are you talking about like with the triangles? Okay, so something like this. So this is geometric mean. Woof, that's a bit off. Okay. These are difficult diagrams to to draw. Okay, so we'll do this. There we go. That's a right triangle. Here like this. Okay. So we've got this one, and then we've got here to that, right? Okay. Okay. All right. So when we are looking at this, okay, Presley, this is what you're talking about? Okay. So we've got two triangles going on, okay? So the geometric mean is where you basically would you look at the, okay. It's basically looking at two similar figures. Okay, you're looking at two similar figures, and in similar figures, remember the proportions are the same, right? The proportions between the legs are the same. So you would have like the short leg over the long leg, and that's going to be equal to the short leg over the long leg. Okay, so like the short leg over the long leg in the smaller triangle, maybe triangle A we'll call it, and then short over long in triangle B we'll call it. Okay, now the reason we know that these are similar is because we've got them coming from the same triangle. So we're kind of cutting this triangle in half. This is a right triangle. These are becoming two right triangles. So we know that they are similar triangles because of the way that the angles work out. Okay, so that's really important that we know that. So what I'm going to do is I'm going to split these up, and I'm going to kind of take this one, and take this triangle, we'll call it triangle A, and I'm just going to kind of turn it a little bit. Because I find that it's much easier to do it that way. Okay, so see how I kind of took it and just went whoop, and I turned it that way. Okay. So now X, which was here, is down here. A, which is here, is here. And then I'm going to leave the other one just as it is. Okay. That's B, and this is X. Okay, so again, I just kind of split them up, right, and I turned it over, right? Okay. So now I know that these are similar, right? I know these are similar triangles because they came from the same triangle. So now I'm going to set up my proportion. I'm going to grab a red marker. Okay. I'm going to set up my proportion with, let's say this is short over long. This would be A over X, because X in this case is my long leg, right? And then over here, my short leg is X, and my long leg is B. So now with this proportion, right, I can crisscross multiply those. So I have X squared equals A times B. So then if I'm solving this, I would square root both sides, and I get that X equals the square root of A times B, whatever that is. Okay. Okay, now I would say, those of you who were asking for SAT and ACT, I know I've seen a problem like this on the SAT before, or on practice SATs at least, like previously released versions. I know I have seen this. Okay, because most people will go, oh, well, then it's A over X is B over X. All right, that's a really tricky one there. Okay. All right. Okay, so Brax Lins, the discriminant. Oh, good, Presley. Okay. If you're working on some practice or something right now and you need me to go back to this, if you have like a specific problem, let me know and we can go back to it, okay? All right. Okay, so let's see, polynomials long division. Okay, so I'm going to do, so solving quadratics, we can use the quadratic formula. That's a banger of a song, right? X equals negative B plus or minus the square root of B squared minus, I was saying minus and I wrote plus, minus 4AC all over 2A. Okay, and this comes from the standard form of a quadratic, which is AX squared plus BX plus C. Okay, so you would use all of these numbers in here and you would plug them in and you would solve. Okay, the discriminant is this part right here. It's It's the b squared minus 4ac. That is called the discriminant. And it can tell you some information. Discriminant. Okay. It can tell you some information. For example, if it is a negative number, I know that none of my solutions are going to be real numbers. They're all going to be imaginary. Okay. My discriminant, if it is a positive, if it's a perfect square, that would be lovely, because then it would be a real rational root. That would be nice, right? So those are the main things that you're looking for, is are they going to be imaginary or are they going to be real rational numbers? If it's not easily square rootable, then it's going to be an irrational number, but that's okay, because it just kind of is what it is, right? But the discriminant is really just used for you to figure out how many different solutions there are. Okay, if the discriminant is 0, then it's going to be, there's just one solution and that's it. Okay. Okay, so coordinate plane. I've seen a couple of people asking. Let's see. Okay. All right. Yeah. Braxlin's, that's literally all it is it's just that b squared minus 4ac. That's the discriminant. And so it can tell you that information, right? But you can also, like, if you're just figuring out what the roots are, like for me personally, when I'm working these out, it doesn't change what I'm going to do for solving this problem, knowing that it's going to be imaginary or not. I just kind of work it through and I go, they're all imaginary. Go figure, right? But when you get into more complex polynomials that you're solving, if you're trying to see, because if I have imaginary numbers that are my roots, they're not going to show up on my graph. So that will help you figure out, like, oh, there are some roots on there, but they're, not real. They're imaginary. All right, Nicholas, stop it. You have to give me more information about the coordinate plane. Okay, I'm about to help you, but you got to give me more information. So are you talking about plotting points, graphing lines, anything? Okay. All right, so let's see. Perpendicular bisector, let's see. Okay. All right, Nicholas, I see what you're saying. Okay, so plotting points. So when we're plotting points, when we look at the coordinate plane like this is our x-axis and this is our y-axis. Okay? So when we're looking at these, and if we're given a point like 2, 3, okay, the x and the y-axis are just number lines. Okay, so what you're looking at is you are looking at where this point is at the intersection, right, where you've got 2 for the x value and 3 for the y value. So it's always x comma y. Okay. So I always start at this center point, which is called the origin, okay, and that's 0, 0. So we're going to go, we have to walk out before we can take the elevator, okay? So we're going to walk to our x value, and then we're going to go up or down for our y value, wherever that is, okay? So to the right is positive, and up is positive. To the left is negative, and down is negative, okay? So I start at my origin, and I go out to 2, and then I go up to 3. And that right there is my point. Okay, so I went out to 2, and I went up to 3. So now if I had something like -3, 2. Okay. Then I'm going to go from here, and I'm going to go To the left 3, that's negative 3. And then up to 2. That's where that next one would be. Okay, so plotting points is really just looking at the x and the y value and where they would meet, right? And you can also do this by finding, if you like find where your x value is and find where your y value is and kind of follow the lines and go there, you can also plot them that way. Okay, that's just another way to do it. Okay, but it's really just looking at where these two values are kind of coinciding. Okay. All right. Okay, let's see. All right, Nicholas, you good now? Okay, let's see. All right. Okay. Getting a lot of questions for polynomials. So let's see. Okay, good. Okay, who is that person? Where is my something? Where is Millie, maybe? Can you teach me how to do polynomials? So I will start, you know what? Oh, Charlie, here. Pythagorean theorem. I needed a Pythagorean theorem earlier. There's a Pythagorean theorem. So Pythagorean theorem is really, it's the legs, leg squared and leg squared equals hypotenuse squared. So that's what that is. It's just to find the sides of a right triangle. The side lengths are always going to occur in the same ratio right there. Okay. Okay, so I'm going to do polynomials. I'm going to do as much of the polynomial stuff as we can do, including simplifying radicals. Okay. In fact, why don't we start with that? Why don't we start with simplified radicals? Let's start there. Okay, because I did kind of mention it briefly earlier. Okay, so a radical, right? So the radical is the square root, right? So square root of 9 is technically plus or minus 3, right? Now, when we're talking about polynomials, it is important, I should say, when we're talking about radicals, when you're talking about Pythagorean theorem, you can always assume that it means the positive version, because if you're talking about the side length of a triangle, like, it's got to be positive, right? We're not talking about vectors and direction and all that. So when we're dealing with polynomials, though, polynomial equations, you're finding solutions on the graph, so they can be positive and negative, okay? So square root of 9 is plus or minus 3 when we're talking about, like, x equals square root of 9. So x could, if x were 3, it would work, right? Or actually, let me say this. If I had x squared equals 9, okay? So then that means that x is going to equal the square root of 9, which means that x is either negative 3 or x could be positive 3, right? Because you've got either, so if x squared equals 9, well, negative 3 squared does equal 9. X squared equals 9. Positive 3 squared also equals 9, okay? So usually when you've got these, when we're talking about polynomials, that's when you really start to be concerned with the fact that it's a plus or minus, okay? Let's see. Okay. Well, so, guys, I've got news for you. I didn't go to school for math either. I went to school for science. I'm still a good math teacher, so. Okay. Cut your teacher some slack. All right. Let's see. So with polynomials, so simplifying radicals. So square root of 9 is plus or minus 3. So square root of something like 27, okay? Now, square root of 27, I can't do, well, I could look at what square root of 27 is, right? So let's see, square root of 27 is 5.1961524, blah, 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 blah. Not going to be great, okay? But what I can do is I can simplify it, okay? So the root 27, the root of 27, 27, let's just look at 27, right? 27 can be factored into 9 times 3. Okay, now I could keep going, right? And it's 3 times 3 times 3. Yes, I got that, right? But 9 is a perfect square. I could take the square root of 9, right? So square root of 27 is the same thing as square root of 9 times 3. Well, the square root of 9 is 3. I can't take the root of 3, so this would end up being 3 root 3. Okay. If I am just simplifying the radicals, I would leave it as 3 root 3. If I were talking about how this is a solution, right, it would be plus or minus root of 27, that's when I would do the plus or minus 3 root 3, okay? So the whole like plus or minus, or it's just the positive or just the negative, it all depends on the context, right? It depends on, does it really matter if it's the positive or the negative? When you have x squared equals 9, yes, it does matter because x could be 3 or it could be negative 3. In this case, I'm just simplifying it down. I'm just saying the root of 27 simplified is 3 root 3, right? So the vast majority of teachers are not going to count you off for saying that, for not saying it's plus or minus, because by default, you really just mainly focus on the positive version of it, right? Okay, let's see. Let's see. Okay. 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 Just making sure we're not missing a lot of things. Okay. All right. So this is simplifying radicals. So polynomials. Okay. So polynomials, I'm going to mainly focus on quadratics because I think that's where most people are struggling with this. And the reason I'm kind of distinguishing between polynomials versus, or why I'm specifically saying quadratics is, so a quadratic is where quadratic functions, okay, is going to look something like this. So you've got ax squared plus bx plus c. Okay, so this is the standard form of a quadratic function. Okay, so this right here, f of x, this does not mean f times x. This means f of x. This means the function of x. So the function of x, which on a graph, it's just y. F of x is just y. But f of x is ax squared plus bx plus c. So to solve this, well, if I were to graph this, let's say if I were to give you a different function, and notice how I'm saying a different function, I'm calling it g of x. So function g is, let's say, 2x squared plus 3x minus 4. Okay, so 2x squared plus 3x minus 4. This is going to look, I'm going to do this. So this quadratic, when you graph it, okay, and I'm going to just kind of do I'm going to show it on the well, oh, these calculators are so hard to see on here. No, clear. Clear. There we go. Okay. Here I've got, let's see, what did I say? I said 2x squared plus 3x minus 4. Okay. All right, so my quadratic is looking something like this. Okay. It's going to look something like this. Now, all of these quadratics are going to look basically like this, okay? When it's a quadratic equation, which means that it has a 2 for the exponent, okay? That's the highest exponent of the 2. We call it a degree This is a second degree polynomial, which means it's a quadratic. Okay, so it's always going to have this shape, which is called a parabola, or a parabola is what it looks like. So a parabola, it's going to open up because this one is positive. If this one were negative, it would be opening down. Okay, so here we've got opening up, and my y-intercept is -4. Y-intercept never changes. But when you're asked to solve a quadratic, okay, what you're really looking for are these two values here, which are called the x-intercepts, which are also called the roots. Okay, so there's different names for these things. So you might hear these. So like, I'm going to put it in quotations as like solve, because this is what you're solving for. So solve the quadratic means that you're finding these things, which means that these are also called the roots. It is the x-intercept. It is the zeros. These are all different things that you call the same thing, okay? Ultimately, what you're trying to find is this is where y equals 0, okay? So all of this to say you're just trying to figure out where y equals 0. So if you want to figure out where y equals 0, then what you do is, well, I mean, if you can't really plug it into the calculator, right? So the direction of the parabola, like I said, it's based on the a value. If it's positive, it opens up. If it's negative, it opens down. This part down here, this is the vertex, okay? But we're not going to get too far into the graphing because I want to make sure we have time for the solving. So when you're solving these, if you're trying to figure out where y equals 0, then when you're solving them, you're going to set the whole thing equal to 0. So I'm going to say, all right, if I'm solving this, I'm going to say 0 is my solution. Now I got to figure out what my x values are when it is 0. Okay, so when I'm doing this, need some more whiteboards. When we're doing this, now I'm looking at, okay, I've got to solve this and figure out what values for x are going to give me 0. Now, when we see this x squared, we kind of go, uh-oh. If we think back to like x squared equals 9 and it's plus or minus 3, right? Then we can kind of see like, oh, this is going to give us multiple answers, right? And even when we look at the graph, we see that there are two different values that are going to be there, right? So what we can do is we can check to see, is it factorable? Okay. You don't have to double check if it's factorable or not, but you can, okay? I like to just double check if it's factorable because I love factoring. So I do 2 times -4, that's -8. And then I want to see, are there two numbers that multiply to -8 and add to +3? So I could have 1 and 8. I can't make those equal 3. 2 and 4. Can't make those equal 3. Even if, and what I say by like I can't make them equal 3 is like if I play around with the positives and negatives, it's not going to be, what is in my water? Oh well. I can't play around with the negatives and make them add together to equal +3. Not factorable. So now I do quadratic formula. So this is where the quadratic formula comes into play. Now, quadratic formula always works. You don't have to check if it's factorable or not unless your teacher's making you, okay? You can just jump right into the quadratic formula. But sometimes if it is factorable, it can be really way more efficient to just factor it as opposed to quadratic formula. But in this case, can't factor it, quadratic formula. So we have x equals -b plus or minus the square minus 4ac all over 2a. Okay? So my a, b, and c values are all going to come from up here, from my equation. A is 2, b is 3, c is -4. Plug it in and see what happens, right? So we have x equals -b, which would be -3 plus or minus square root of 3 squared minus 4 times 2 times negative 4 all over 2 times 2. Okay. So once I plug all this stuff in, once I put all of these values in, okay, so here's my formula, and I'm just putting in all of my values there. Okay. I'm not going to just put this all into my calculator. First of all, it's hard to put in a plus or minus to your calculator. But I'm first going to figure out my discriminant. I'm going to just kind of break this down calmly, right? So I've got 3 squared minus 4 times 2 times negative 4, which is 41. Okay, so this is going to equal negative 3 plus or minus the square root of 41. So all I did was that's my discriminant, right? So my discriminant is a positive number, so no imaginary values. But it is not a perfect square. Bummer. So now I'm just going to leave it as a radical. Okay. Root 41, I cannot simplify it. I can't simplify it. So actually, this is my solution. These are my two values. These are my two roots. I know it crossed in 2 spots. So my first root is, so x equals, now some teachers will let you just leave it like this, totally fine. But I'm going to split it up just because. We've got negative 3 minus root 41 over 4. Or negative 3 plus root 41 over 4. Okay, so we're going to have a negative root and a positive root. And there we go. Okay. So not easy, but pretty simple, pretty straightforward, right? Pretty straightforward when you're doing your things right here. Okay, when you're plugging in your values onto these things. Now, those of you who were asking for polynomials, is there anything else that we can do to help you? Sorry, I was going through all of this. Let's see. Oh, I love how much you guys all help each other in these chats. It is really awesome. Oh, Regents test. Okay. Regents. Great, great, great. Sarah, math is not so gross. Okay. Oh, that's right. We did want to do polynomial long division. So when the radical does simplify, you would simplify it out. So let's look at that. So if I had a radical, that did simplify, and then we'll do long division of polynomials. I know somebody was asking about that. So if the radical does simplify, okay. So this is a different problem, so that's why I'm doing my little squiggle. Okay, so let's say I had negative 4 plus or minus the root of 44 over 6. Okay, so let's say that that's what we got from our quadratic. Okay, so root 44, I can simplify it, but it is not a perfect square. But root 44, sounds like I'm talking about a freeway. So root 44 is 4 times 11, right? Which would simplify down to 2 root 11. Okay. So now what I do is I would write just that. So I would have negative 4 plus or minus 2 root 11 over 6. Now I can simplify this even further because I look at all my coefficients, right? Well, I look at my 4, I look at this 2, and I look at this 6. Okay, and I can divide all of these by 2, so I can simplify it like a fraction. So what this would actually end up being is x equals -2 plus or minus square root 11 over 3. So that would be the simplified version of that number or that value. Okay, is you would simplify the radical, and then you also want to make sure, are these all divisible by the same thing or not? Okay. Okay. All right, so we'll do, let's see. How do you, Zoe, the exact values of an inverse trig function or of any trig function, when it says exact values, they really just mean to leave it as a square root or leave it as a root. So if you have it where this is 4 and this is 5, right? So then the third side would be square root of 4 squared plus 5 squared. So that would be square root of 41. Huh, that's funny that we just did that. So square root of 41, right? And I just did that by doing Pythagorean theorem, right? So then sine theta, if this is theta, so sine is still going to be the opposite over the hypotenuse, which would be 5 over root 41. Okay, you would probably need to rationalize this denominator. So you would do that times, you would multiply by the root on both of these. So you would end up with, so sine theta would be 5 root 41 over 41. Okay. So that's just if your teacher won't let you leave the radical in the bottom. But again, whenever you're asked to find the exact value just means don't round this, leave it as root 41, right? Just like 2/3 is not the same thing as 0.6 or 0.7, right? The exact answer is 2/3 or 0.6 repeating, right? Okay. So then the last piece that I promised that I would do is dividing polynomials, long division. Okay. So long division of polynomials. Let's see. Okay. Okay. All right, long division of polynomials. So if I have, let's do, you know what, actually, I got myself into trouble a little bit with this last time. So I want to have a good example. It'll work out nicely. I'm okay with a remainder, but okay. Actually, let's do this. 2x squared plus 7x minus 4 divided by x minus 3. Okay, let's see if this works out. Okay. Okay. So, polynomial long division is just like long division, the algorithm that you learned way back when. Okay, we put this number, right? The big number, the bigger one goes inside the little house, and outside stays the littler one, right? Now, as you're working through this, you're still going to do, again, you're still going to do the same basic concept that you did when you were dividing numbers by each other, okay? But I'm only going to pay attention to the first term in each line. So I have x here, and I have 2x squared. So what I'm looking for is, what do I multiply x by to get 2x squared? So think about like 2x squared divided by x would give me 2x. So 2x goes up here. I multiply 2x times x minus 3. And I put that down here. I have 2x squared minus 6x. Because 2x times x is 2x squared. 2x times negative 3 is minus 6x. I'm going to subtract. Those cancel out. 7x minus negative 6x is going to give me 13x. And I bring down the negative 4. Now I look at my next thing. Right? X, 13x. Well, x times 13 is 13x. So I do plus 13. I multiply through. So I've got 13x minus, let's see, 13 times 3 is 39. Just subtract that. Those go away. So I have negative 4 minus negative 39. So that's going to give me 35. So my remainder goes over this. Okay. Why is it 13x when you aren't adding 6x to 7x? You are. It's 7x minus negative 6x, which would be 13x. Okay, so my remainder is 35, so this would be plus 35 over x minus 3. Okay, so if I were to multiply this times this, I would end up with 2x squared plus 7x minus 4. Okay. Oh, I would absolutely do synthetic division on this. But again, synthetic division doesn't always work very well, right? Synthetic division, if you look at this and if this coefficient is a 1, absolutely do synthetic division. Okay? So just to contrast, let's do this one with synthetic division. So with synthetic division, you're just paying attention to the coefficients. So synthetic division, I can do it all in this one little tiny bit. Okay? So here, this is x minus 3. So out here, I'm going to actually be looking at plus 3. I'm going to list my coefficients. Sorry, I had to extend it a little bit. 2, 7, and negative 4. I bring down the 2. Okay. I do 3 times 2, which is 6. I add them together. I get 13. I get 3 times 13, which is 39. I add them together. I get 35. These become my new coefficients. This last one is my remainder. So that is 2x plus 13 plus 35 over x minus 3. Way faster, way more efficient. But again, it doesn't always work. Or I should say, well, it doesn't always work, but it also is not always the most efficient way to do this. Okay. Okay, so guys, it is 9:30, so it is time to go. Okay. So if you guys are looking for more help, if you need one-on-one tutoring, if you have any questions or anything that you want me to put on the list for next week on Thursday, I'm here every Thursday, as much as I can, right? Last week, I was in DC with a bunch of 10th graders, so I was recovering from that. But yeah, so send me an email, send me a message, and, follow, share, like, subscribe, all that good stuff. Have a good night.